Alright, this will be video demo of the whole setup here. So to give a brief overview, we kind of have the linear actuator here with a piece of wood to weigh it down, the sliding potentiometer here, the Arduino microcontroller, a small little board that's mainly used for power, and an external computer which is hooked up to the Arduino via USB that is hosting LabVIEW. So the main brain of the operation, or at least kind of the center of it, is the Arduino, which has a lot of in and out pins. It's going to be controlling primarily the linear actuator and sensing the positions of both the potentiometer and linear actuator. The actuator itself, with these wires here, takes a 12-volt source, which is up here, and that is driven down into this little board, which its only real purpose is to take that 12 volts and kind of split the grounds and have one ground go to the linear actuator wires and one into the ground pin of the Arduino, so that way they're all kind of on the same level and they can interface. The linear actuator also has a position feedback on this, which is sent into the analog input of the Arduino. And the actuator position itself is dictated by a PWM signal, which is generated by the microcontroller, and I have probed up here and I'll be referencing. And as you can see, it's kind of screwed in to these wood blocks. One wood block is for the potentiometer here, and one is one to kind of weigh the whole thing down, a bigger one. The potentiometer slides back and forth like this. For the wires here, it has red and black go across the 5 volts of the Arduino, and then the green wire is the analog signal of the potentiometer. So as it slides, that signal goes from 0 to 5 volts depending how much you slide, and that goes into another analog input of the Arduino. As you can see, this is also bolted on, and it has this kind of spring which I've glued on. This spring kind of gives a bit of resistance when you pull on the thing. It also allows the potentiometer to kind of have a default position. And then, of course, USB to the LabVIEW. So the Arduino, to summarize, it reads in the position of the linear actuator and the potentiometer and uses that to judge the correct output on the PWM to drive the linear actuator. And we'll be looking at that once I get it running. And then LabVIEW here is essentially the user interface. So we have a few things going on here. We have a difficulty level, which is just a number 1 through 5, 5 being the hardest, that the user selects. They can generate a text file or not. It displays the different parameters right here on these graphs. It estimates the total movement, which is found with a kind of integration. There's a stop button. This little light will light up once the program starts running, just to show that it's running. And this little sidebar here is kind of the data collected and is mainly used for debugging, but also kind of shows that it's working. In the advanced settings, it's pretty much just the COM port for the USB, which they would have to specify, but that's not too hard. So, to kind of demonstrate how this thing works, so I'm just going to set it on difficulty level 1. I'm going to generate a text file, and then click go. So now that's running. So first, the patient would put their arm kind of on the potentiometer like this, and they would have to move the potentiometer past a certain distance, and once it gets to that certain threshold, the PWM signal changes a set amount, which changes the position of the linear actuator. Now this is a set distance depending on the difficulty level, and the threshold it needs to move past also depends on the difficulty level. And when you first initiate a movement and it changes the PWM signal, the Arduino calculates with the position feedback where the linear actuator is supposed to end up and waits for it to get there before moving on and getting any more signals. So that means it kind of moves in steps, but if they do it right, and the actuator kind of helps them move their arm like this and gets this movement, it can be pretty continuous. And And as you can see, right here the PDOM was nearly 100%, which meant it was a full extension, and then it dropped back down to 0. So, in order to successfully complete a trial, the patient has to move out this linear actuator the full distance. As soon as they start moving, they have a set amount of time to do that. So if they don't do that, let's say like they only get like a little bit far, only like so far, and then it moves back after the time runs out in a little bit. Yes. The difficulty, the Arduino will sense that the patient attempted a trial and then failed. So then it will get easier, meaning that the distance that you have to pull on this is shorter. As you can see, it just kind of moved there, and the distance this moves is now longer. So, alright, it's pulling back again, which means it's going to get easier again. And if I go perhaps the full distance, and again, this kind of helps. This movement pretty much does the work for them, as far as like kind of a small reaching motion. So now that whenever they successfully complete a trial, meaning they go the full distance within the time allotted, the trial gets harder, meaning that the distance the linear actuator moves per step is smaller, and the distance they have to pull is bigger. So, as you can maybe tell, that's a little bit smaller. The PDOM signal isn't as large. And then another step, and so on and so forth. So they would continue to do that, and if we go back to LabVIEW, we can hit stop, and then it'll ask to specify where we want the text file to appear. So I'm just going to overwrite this text file right here, the test one. And as you can see, this is the plots of the actuator position, the arm position, and the difficulty levels. So as you can maybe see, the difficulty levels kind of spiked and peaked over time. Same, there's kind of some spikes of movement, as you can see, that we just did to demonstrate. Same here, and then it would also kind of integrate these over time to give you the total values right here. Here's kind of the array that the data it got through serial that spit out, and if we open up the text file that we just generated, you see we have the parameters up here and how it changes. It sometimes takes a little bit for it to really change, and it converts the units into, hang on, sorry, I'm trying to work the computer through the camera. Yeah, there we go, there's some. It calculates it in like inches and things like that. So, I think that is a good amount of it. I can get into some issues that this thing has. First and foremost, this power situation I don't think is totally ideal. This thing actually takes, or the actuator takes a good amount of current while it's moving. It could take like up to 100 milliamps and stuff, so I wasn't able to adequately get a good battery or something that would help drive it efficiently. On top of that, this has been happening a bit more recently, but sometimes this program crashes in that I think it's an issue with my computer or something more than just LabVIEW. Like, but the computer would blue screen after running. I think it's some kind of data issue or something. Yeah, it worked now, and it works usually. And I think that's more of an issue with my computer than the actual program, but it has happened. That's mostly it. To kind of summarize and to get more of a demonstration, I mean, they try and pull on this and it kind of gets the work for them. They have to keep pulling on it. The thing adapts in difficulty depending on what the trial or how they do. Whether they complete attempts, don't complete attempts. If they fail many times in a row, it can actually exponentially make it easier. And the blocks here help kind of weigh it down so it can move both this block, which allows the thing to slide, and the arm. I mean, it needs to kind of carry a human hand and arm. Now, eventually, as they get better in moving it, they want to maybe like use just their finger as much, and might want to like try to actually like pull, like actually get a pulling motion. And once we step it up to like difficulty 5, it gets pretty hard. I don't know if you can see, but I just stepped it up to difficulty 5, but you can see now that they need to pull it a good amount, and it moves very small for that amount in difficulty 5, and they don't have a lot of time to do it. So these kinds of parameters aren't exactly the most well balanced because I haven't done a ton of human testing, but they're not super hard to do if need be. So anyway, but you can see if they get going, they can pull it the full way. They completed a trial. It gets a bit harder, so anyway, that's mostly it. I hope this was helpful in explaining this whole setup.